Oh, you put it there. This
Okay.
one is not here. Yeah, run it from that. That one is not here.
Yeah.
Then we call Diego, and then we follow that.
Diego.
And then it seems like Dashna is not here.
So Jane is here. I'm calling Diego Molina Montano. Yes. For Gascon, Prac Tom, Serge Ilonga, Abdul Aziz. Please.
Are they coming? Yeah.
We can start, I think.
Yeah, we will start. Let me just make small announcement. Good morning, colleagues. I think the chairperson is requesting all the speakers just to come forward. In the meantime, while they are coming forward, let me just make one announcement. We are requesting that mostly the EIA delegation need to pay a $100 subsistent fee just to cover the cost in front. Please don't forget that we've got our finance officer in front. Please make sure that you make the payment before you leave today. Thanks. Bye-bye.
Okay. Thank you, Sami. So you are welcome to this session, which concerns the research reactor operation and maintenance, including the aging management. First, I would like to invite Mr. Diego Molina Montano to present his paper about aging management controls for RB01. Mr. Diego, you have the floor.
Hello, good morning. My name is Diego Molina. I'm from Bolivia. I am working in Bolivian Agency of Nuclear. My topic is Agent Management Control Program for RB1 Research Reactor, the field reactor of Bolivia. This is the outline. Number 1, opening remarks. Number 2, introduction for RB1 project. Number 3, objective of the agent management program. Number 4, scope of the program. Number 5, fundamental of agent RB1, agent management strategy, controls during assembly, controls during operation, metal condition control program, risk assessment, and conclusion. Number 1, opening remarks. Bolivia is implementing its first nuclear research reactor, the RB1, located in the Center for Research and Development in Nuclear Technology in the city of El Alto, Bolivia. This project represents a major milestone for the country. Due to the fact that the RB1 is a new facility, Bolivia has the unique opportunity to integrate agent management and safety concept from the very beginning, even before the start of operation. The research reactor RB1 is currently under construction, carried out by GSPA Rosatom, the company responsible for the design, manufacturing, and installation of the reactor system. As the facility is still in the assembly stage, agent management activities are being integrated from the very beginning of the project. The relationship with the RB1 with final safety analysis report, the aging management program is aligned with the safety and reliability requirements established in the RB1 final safety analysis report. The FSAR identifies the safety-related structure, system, and components, their functions, and the conditions that may contribute to degradation during the reactor lifetime. In this sense, the AMP uses FSAR information to determine the safety classification of SSC, identify environmental and operational stressors, temperature, humidity, radiation, corrosion, and vibration. Support the selection of inspection intervals and monitoring methods. Establish acceptance criteria and corrective action for aging effects. This ensures consistency between reactor design, safety analysis, and the preventive aging management activities implemented during pre-operational and operational phase. The RB1 research reactor with a nominal terminal power of 200 kilowatts is a pool-type reactor currently being assembled as part of the Bolivian nuclear program. The RB1 is a part of the Center for Research and Development in Nuclear Technology, and its main objective is scientific research, human resource training, and the production of radioisotopes for medical and industrial use. Within the framework of the safe and sustainable operation of nuclear facilities, aging management is an essential component of the nuclear safety management system, according to International Atomic Energy Agency guidelines. Age management for research reactor, SSG-10, age management for nuclear power plants, NSG-2, and the management system for facilities and activities, GSR-3. This document presents the main age management controls proposed for the RB1, considering its construction status and the need to establish an age management program prior to start of operation in order to preserve the safety, availability, and reliability of the reactor throughout its useful life. Objective of the aging management program. General objective: to ensure that the structures, systems, and components maintain their functional capacity throughout their expected operational life without compromising safety functions. Specific objective: identify the degradation mechanisms that may affect SSC, prevent and detect and mitigate the effects of aging before they reach critical levels, plan inspection and maintenance according to safety importance, integrate the PGA into the overall facility management system, comply with the regulatory requirements of the International Atomic Energy Agency, Bolivian Regulatory Authority, foster a safety culture focused on its constant monitoring of the condition of SSC. Scope of the program. The PGA covers all structure, system, and components whose degradation could affect nuclear safety, radiation protection, or operational reliability of the reactor. Components include reactor vessel, pool tank, metal structure, and lining, primary and secondary cooling system, fuel elements and support structures, ventilation and HVAC system, electrical system and control and protection instrumentation, biological shielding and concrete structures, laboratory components and irradiation lines. Type of agent: physical, chemical, radiological, and technological obsolescence. Fundamental of aging in RB1. Aging is defined as the process of gradual change in the properties of a component over time due to operational, environmental, or radiological factors. Most significant mechanism in RB1: corrosion, radiation degradation, thermal fatigue, aging of sealing materials, and obsolescence of electronic systems. Aging management strategy. The RB1 strategy follows a systematic and preventive approach based on SSG-10. Identification of critical SSC, evaluation of degradation mechanisms, determination of early detection methods, implementation of periodic monitoring and inspection program, documentation and traceability, continuous feedback and program improvement. Control during assembly, quality plans, verification of materials and quality certificates, review for welding procedures and operator qualification, non-destructive testing, and critical joints, ultrasound, radiography, penetrant testing, documentary record of installation, history, and pre-operational testing. Controls during operation, monitoring of critical system parameters, temperature, flow, pressure, and water chemistry, periodic visual inspection and NDT of metal structure and components, chemical control of cooling system water, functional testing of protection and alarm system, periodic calibration of instruments, scheduled replacement of critical components according to service life and operation condition. Metal Condition Control Program, development according MP 8450 and 8950. Stage, pre-operational baseline, review of procedures, certificates, and NDT records. Operational phase, periodic NDT and comparison with baseline. Acceptance criteria, corrective action for deviation detected. Risk assessment, examples, primary cooling pump, degradation for vibration fatigue, impact, flow reduction, safe fit impacts, action, vibration monitoring and schedule replacement. Reactor vessel wells, degradation for corrosion, impact, leak age, radiological implication, action, periodic NDT, immediate repair. Conclusion, the RB1 age management program is essential to ensure the safe, reliable, and sustainable long-term operation of the reactor. Early implementation of aging management control during the construction and assembly stage ensures components integrity, regulatory compliance and personal protection fully aligned with the International Atomic Energy and safety standards. In addition, incorporation aging consideration into the design, construction, and documentation process strengthens the safety culture and provides a solid baseline for future inspection, monitoring, and decision-making. As RB1 is a Bolivia field reactor, the proactive adoption of aging management practice not only supports safe operation, but also contribute to the development of national capabilities in nuclear technology and a long-term infrastructure sustainability. Thank you for attention.
Thank you, Mr. Montano, for this presentation. Now the floor is open for participants' question. Is there any question? Yeah.
Hello. Yeah. Thank you, Diego, for this presentation and for traveling so far from your country. Yes, it's a very good news that you are taking seriously the aging management from the construction phase, because most of the reactors that are 60-year-old, 50-year-old, they realize the importance of the aging management late in the process of the operation. So it's a very good news that you are taking measurement for this from the beginning, no? Which is the most effective way to manage aging management and to get better results. So no, my question is, I was a little bit anxious because I expect to see some pictures of the construction now, and we would like to know if you can describe in some way what is the status of the reactor today, and what is the prospect to get the reactor online in operation in the future.
The status of the project in this time has a 15% of construction, and the next year I waiting start operation.
when do you expect to complete the construction phase?
Year, December the next years. Yeah, 1 year more.
Another question? Is that a question here? Hand, please.
Good morning. Sorry, get used to the distance. Thank you for the presentation. I have a question. So Rian Prinsloo from Nexa here in South Africa. Stand up. Yes, sir. Just related to the opening remark of the previous question, could you elaborate on where you think the definition of maintenance to reach normal end of life starts and stops, and where aging management starts and stops? I just found myself now also interested in the fact that you are calling it aging management from the start of the reactor life, which is probably a very good idea. But how do we distinguish between what is just standard maintenance and what would be classified as aging management?
The maintenance, we working with my technological provider, GSPA, for have this document and start of the begin with the operation. I need talk with GSPA Rosatom for give a good answer for this question.
Other question? I have a question for you. So, as mentioned by Dr. Amazi, this is something important that an aging management program is established since the construction of the facility. It is very, very important. Now the facility is under construction. It will be different stages of the lifetime of the facility: construction, commissioning, including cold commission and hot commissioning, and after this, the operation. Can you give us an idea about the impact that can be raised from, for example, the commissioning, the result of commissioning on the aging management program?
Okay. For Bolivia, take this aging management program is very important for has a safe it, take a safe it, and we are thinking take this action before start of operation. We have a good project and good action for can produce and have a good persons, good training of resource, and we have start the very near time for action for produce.
Thank you. Another question? So thank you so much, Mr. Montano. So now I will be pleased to give the floor to Mr. Phongsakom Prak Tom. I'm sorry for not spelling in appropriate manner your name. Sir, you have a presentation about the aging management of the post-Patriga reactor, a framework for long-term safety and performance. You have the floor.
Hello. Thank you, Mr. Chairman. Good morning, everyone. My name is Phongsakom Pratom from the Safety and Engineering section, rector in Malaysia, so from the Malaysian Nuclear Agency. So today I'm going to present about the aging management of the Reactor 3 Puspati, or we call RTP, a framework for long-term safety and performance. this is my content. So I will briefly talk about the RTP and the framework of the RTP Aging Management Program, RTP Aging Management Program Implementation Strategy, some examination activities that have been done before, then data management and record keeping, finally with the conclusion. This slide show the Rector Tiga Puspati briefly. So we achieved the first criticality on June 28, 1982, which means now already 42 years, and a license under LPTA is 1026, and we have 34 personnel, 17 certified operator, including 5 senior rector operator. So the rector is only one in Malaysia. We only have one, and operating by Malaysian Nuclear Agency. The type of reactor is trigar, and the power is 1 megawatt thermals. Now, currently status is under still operation, and we operate 1 day a week for at least 6 hours a day. This is the description of the reactor. There are trigar Mark II types, and the power 1 megawatt thermals with highest neutron flux at 1 time power 13. And our fuel is uranium zirconium hydride with enrichment 19.9%. So the coolant, we use demineralized water, and then natural convection cooling system, natural convection cooling system, and we use the primary and secondary cooling system as a heat radiation, graphite as a reflector, and we have 4 control rods using boron carbide. This is frameworks of RTP Aging Management Program. Actually, they using SSG 10 as and IR2G 5.2 as a reference. I think it's all about the approach, the screening of SSC, aging detection mechanism, detection and monitoring, minimization, mitigation, and correctivation, review and improvement, and also record keeping and data management. This is the strategy. At first, we have to clearly define the organization responsibility, then do the assessment as data collection, screening, and aging mechanism. Then the action, we implement surveillance and monitor plan, testing, evaluation, maintenance, refurbishment, and replacement strategy. And finally, is record management and continuous improvement. Then we integrate the aging management program with our current management system. This is a 5 key of a management system: organization, key process, interface with another program, and documentation, and lastly improvement process. The chart below show the organization chart for the AMP, which the highest is the top is director manager, and we have AMP coordinator, and lastly we have 5 AMP officer from each section of our organization. First one is operation and maintenance section, reactor safety engineering section, reactor physics section, instrument control, and quality management section. So we have identified the responsibility for the reactor manager, as appointment of the AMP coordinator, monitoring of effectiveness of AMP, approve and resolve a major AMP action and difference. So for AMP coordinator, just coordinate all activities related to aging management. Then the AMP officer, the one have to do the job, select the SSC, identify aging management action, perform update aging evaluation, implement aging management action, evaluate the AMP effectiveness, and report progress to the management. This is show the SSC of RTP. We divided into several groups, around 18 groups. There's a reactor core components, primary cooling system, secondary system, and others. So the right-hand side show the database of all components. So we collect all data and put it in one database. So we have described where the component, what the manufacturer, who the manufacturer of the component, and when the assembles, expected lifetime, and also how frequency of maintenance we have to. So this database will collect all components in RTP. Okay, this is how we collect the data. Actually, this I give one examples from the primary cooling system. They have several components. Then from the component, it takes one, show the heat exchanger. So heat exchanger, we give the ID and what the materials used in a heat exchanger, and then the manufacturer, when the system start, and also sub-component of the component. So we identify the functional specification as a design heat exchanger for performance. They have how much the flow, temperature in, temperature out, and also design pressure inlets. So we do this for all component and also sub-component, and keep in the database. And for the aging management assessment, actually we are still ongoing. We just finished our frameworks and have received in submission this year in June. So now we are going to implement what we have planned for. Okay, even we just have our program, but we unofficially do some activities related to aging management. This the methods such as visual inspection, monitoring, performance testing, periodic functional testing, and also NDT. So the picture show the one of the activities. We use ultrasonic speed scan for RTP tank liner. The purpose is to detect any corrosion or wall loss of the tank liner. So we find out that our tank liner is still in good condition. Next, the other activities, we use ultra pulse velocity for RTP biological sheathing concrete check, and then we found out that they have some there's just a little degradation of the concrete, but we will do this again next year for continuously checking. So next, the right side, the visual inspection for the grip, bottom, upper and lower grip. So we found that no signs of damage in the upper grids, but for lower grid, we not accessible because this very small, and our camera cannot go too dark, too deep because the radiation. And then also we use a penetration test to check the joint for the piping. And the right one, we use infrared thermography inspection to see the secondary piping. The purpose is to identify abnormal heat pattern, but we find that no temperature difference can be observed. Another one, the routine testing and inspection for RTP includes several of activities, observation of condition equipment and measurement of operational parameter, and samples chemicals of radioactivity analysis. So in September 2008, it's the first time we do the visual inspection on the fuel and our control rod. We found blemish on the surface of fuel cladding. So in 2009, we replaced this control rod. Okay, we integrate our AMP program with the maintenance program. So we will put some activity related to aging management into the maintenance program. So the maintenance was scheduled in annual two major maintenance, annual maintenance and semi-annual maintenance. And then we also have a unscheduled maintenance for the corrective action. This picture shows the replacement of some component or system. Okay, the left-hand side, the changes of shell and tube cooling heat exchanger from shell and tube to two unit of plate type heat exchanger. And then the lower one is the pump. We already changed the new pump in the same time and use SCADA to control the pump. And the right hand side, we are replaced the control system from analog to the digital control system. This picture showed the history of the replacement, refurbishment, and modernization of our SSC. From 1986, we are changing we repair the rotary racks, and then 1989 the primary pump, and until now we just have changed the SCADA system upgrades to monitor all activity from the SCADA, so we don't need to go to open the pump and valve manually. Okay, for review and improvement of AMP, the approach used to review, update, and strengthen the AMP. First is performance metrics, is a key performance indicator, such as a number of aging-related incident, SSC failure rates. Number two is audit and review. We conduct annual internal audits and or annual AMP review to assess the performance and identify the improvement area. The third one is feedback integration. We incorporate lessons learned from the RTP operation, industry experience, and IEA publication to update AMP processes and procedure. This hierarchy of the data management and record keep, we integrate into the current management system. We have 8 levels of documentation levels, from Government Acts, regulation, standard, program, process, work, instruction, form, and also records. And currently we are conducting the improvement or updating our data system from the Excel that we collect all in Excel to put in the one database computerized system. This picture shows what we are under development of the database. For conclusion, the AMP for RTP is strategic, forward-looking framework designed to sustain the reactor safety, reliability, and performance well beyond this original design life. By this systematically integrated AMP process into existing maintenance and safety system, the RTP is fundamentally transformed aging management from reactivity into the dynamics, knowledge, and driven discipline. Crucially, the program is undergoing visual digital transformation. I think that's all. Thank you very much.
Thank you, Mr. Prakto, for sharing with us this interesting experience about implementing the aging management program for your Triga research reactor. Now the floor is open for participants. If there is any question, please. There is a question. Excuse me.
Hello. Thank you, Frapton, for this presentation that was very impressive. It's very thorough and comprehensive, and applies most of the recommendation of the agency. So congratulations. I think you know about the OMAR missions are dedicated to review the operating activities, including aging management. Have you any plans to include an OMAR mission in the future in order to review the plan and probably make recommendations about this?
The aging management review will include in the OMA mission? Yes, yes. We will prepare for aging management also for OMA mission. So we just received INSA mission this year. So now we improving by recommendation. Then yes, we can prepare for the OMA mission next year.
Thank you. Any other question? So, Mr. Practom, I have some questions for you. In my country, we are operating the steam reactor, the trigger reactor, but with the power of 2 megawatts. I am just interested about the aging management program. You involved the different actors, concerned actors in your facility, operators, maintenance staff, safety staff as well. What about your safety committee?
Okay. For the operation and maintenance, we include all our staff in one group, and then we have several sessions to support the group, and then we have to report. We call a committee for rector committee. So any related to the rector, we have to report to rector committee, and the rector committee have to report to the safety committee of the agency, to the big committee from agency. So this is a hierarchy of the safety committee. So from rector, we have our own rector committee. The rector committee comprised of rector major and all head of section. And then if we have anything else, we have to report to the bigger, because committee, safety and health committee in our agency, the bigger one.
Okay, thank you. Other question that I have is that many countries, they started to use EI in the frame of the aging management program. What do you think about this? Artificial intelligence.
Yeah. We think that is important. Even now we are upgrading our SCADA system to control all systems in one place. And then I think artificial intelligence is one of the good options to put, especially for safety and security. So we can see who coming and detect the people and something like that.
What about the INSAR mission that you hosted this year in June? Yeah, INSAR. What about the review with the AI experts? The review with your aging management program?
Yes.
What are the main?
Actually, because this is this year, we just started to have the comprehensive program. So that's why in submission they also recommend some point, because we not fully implemented what we have. So from there, we will from the recommendation we will upgrade our some document and also activities.
Thank you so much, Mr. Bracton. Is there another question? Okay, thank you so much again. So now I am pleased to give the floor to Mr. Serge Ilonga. He will make a presentation about an approach to integrating the aging management program into the maintenance operations of a research reactor in extended shutdown, case of the CGEA TRICO 2 reactor. You have the floor.
Thank you. My name is Serge Lunga, so I work as a mechanical engineer at the TRICO 2 reactor of Congo. This presentation I'm going to present you is about our, I can say, aging management. We are planning to implement in our facility because we don't have yet aging management program. So it's the kind of our guideline of the implementation of our aging management program. So the context of this presentation is that our reactor are in shutdown state of science more than 20 years. So after OMAR mission, EASY, and the INVAP mission, the government has taken the decision to restart because those missions showed that the reactor could be restarted without more difficult. So after that decision of the government, we should do some work to be ready to plan a restart and to evaluate, to do an evaluation of SCC condition against safety requirement of our OLC specification, and to be aligned with the AEA safety standard and graded approach. So our outline is a general presentation of our facility, the general framework of that IMP we want to implement, operational and integration of that aging management program into the maintenance activities, time frame for initial result of the integration of that aging management. So I want to make a small presentation of our facility. Is a TRICO 2 reactor. TRICO 2 it means TRIGA of Congo. It's located at the University of Kinshasa. As you can see, some building in front of is the University of Kinshasa, and the TRIGA is in red. We can read Krenka. The characteristic of our reactor is a TRIGA Mark II, like I said, with a thermal power of 1 megawatt, and we can reach in pulse mode 1060 megawatt, and we have as a moderator the water and reflector graphite, and for existing experimental and irradiation facility, we have four beam tube, one thermal column, one rotary irradiation like we call it lazy Susan. 2 in core irradiation position with pneumatic system. 1 central tube, and out of core irradiation position 1. Oh, sorry. So about the building, the building characteristic is under negative pressure for confinement. We usually around 8, something like this, and pool block concrete has the density of 3.5 ton of density for reinforced shielding, and 2.5 for regional above the core and top. The instrumentation, rod drive, mechanical IC, and rad protection equipment. So this is some system of a Trico 2 reactor. As we can see, we have a core. It's in supported structure reflector, and we have a cooling system with 2 pumps for each system, the primary system and secondary system with 2 pumps, using accordance with the power of the reactor. When the power is high, we use more power pumps, and if it's down, we use the pumps. And then we can see there our confinement system, extraction of air in all of the reactor. So there are 2 system, inlet and outlet, please. So general framework of the AMP for the Trico 2 reactor is planned like this. First of all, we have identification and classification of ACC. At this point, we can say we are at 90% of finish this work. We are at the step of validation of document, the list of ACC selected. And the second step, it's initial ACC inventorying to review existing design, safety and maintenance document of that ACC is selected. The third, identification of potential aging mechanism to adapt preventive action and monitoring method. And the last one will be the validation and the documentation that will determine the appropriate level of attention and monitoring frequency of each SSC within this AMP. So after doing this 4th step, we expect to have this kind of, can say, a list and a matrix, a temple of field for SSC. Then we will have the name of the ACC with technical design from manufacturing and drawing or nomenclature. We will codify each SSA, and that code will include the location of that SSA the emplacement by position of that SSA in the system, and the number, the place or is that SSA. So that codification will have that three part. And the component number location, inventory of assigned to the component code assessment, main function of the SSA, the replacement category. We have to classify each SSA by his capability of replacement, the potential aging mechanism monitoring to that SSA, and then we will get this the kind of matrix of practically we will have a primary pump like with his main material, with his aging mechanism that we have detected, observable effect that we will be select to follow how the aging is going on that system. So for like a pump, we can have a noise, the vibration, the flow, and the monitoring of methodology to take that element. And as you can see, for the heat exchanger, it will be changed. So each system will have especially kind of screening. So for the operational integration of the aging management program into the our maintenance activity, as we can see, the main aspect between these two service, I can say, or section. So there are the approach of the maintenance is based on the maintenance of cycle planned and corrective intervention, but to the aging management will be based on the aging analysis, monitoring, prediction, and documentation of the degradation and the expected result. That is very important, but because we have to work in the clearly definition of things, immediate operational availability, and for the aging maintenance is for the aging management, maintenance of long-term of safety competence. So in the implementation, we will have four main steps. The first one will be logically the identification of that SSA we will follow, and the second one, assessment of the aging mechanism and corresponding monitoring parameter. And the third, it will be adaptation of the preventive maintenance planned based on risk and observed degradation trends. It will be the third step. And the fourth one, it will be integration of documentation and traceability into the plan maintenance management system. All those steps is recommended in the SSG 48, as we can say it. So, operation integration of the AMP into the maintenance activity will have, we can say, for the organizational coordination, The AMP will be integrated by the reactor manager, and inspection, where we will collect the base of the AMP will be done by the maintenance team, and the technical signification of those results by the AMP team. Technical aspect will be the procedure of the preparation, periodical check, and calibration will be written by both teams, because maintenance team know some problems they can meet to each ACC, and the AMP team know what they are looking as information to follow that aging. The correlation with the aging management identifier will be done by the AMP team. So the documentary traceability. So the lesson learned in the maintenance intervention that will be integrated into the AMP database. This data will be used to assess degradation rate, compliance with the acceptance criteria by each ACC. And the continuous improvement, the maintenance feed factual information to the AMP, which in turn optimize maintenance based on the thread analysis. So it will be work as a closed circuit. I don't know if say like this in English. So the time from for initial results of the integration of the AMP, like I said, we start and we are at the end of the first step, and the second one we think that it will take us around 1 year to implement for implementation of the first monitoring measurement, because now we don't have a baseline of that AMP we want to have. And after 2 years, we can have something and to give us some perspective of this AMP. So expected periodic for observable result. We will start with the stabilization of reference parameters that we will have as a vibration, sound for each system. You'll have some kind of parameter, and that will be compared to know how the aging is going on each ACC. The reduction of the number of unplanified corrective intervention for maintenance, and early detection of slow degradation phenomenon on the particularly in the hydraulic circuit filter by the inspection we will make, and the production of initial trend report. So concretely, concrete on the operational result of the integration is expected at the end of 26 or at the beginning of 27. So as a conclusion, we think that the integration of the aging management program strengthens the safety and the reliability of the trichotor reactor. The structured assessment of SSC aging management support proactive maintenance and long-term operability. The combined AMP maintenance approach announce compliance with the AAA safety standard and prepare the reactor for the safe restart. The work completed lays the foundation for continuous improvement of optimized surveillance and informed decision making for future operational phase. So thank you.
Thank you very much, Mr. Ilunga, for this presentation. All the best with this integration of the management activities within the framework of maintenance program. Now I am pleased to open the floor if there is any question from participants. Question?
Hello. Unless I'm misunderstanding, you're still going to restart the reactor. So if you're still going to restart it, how are you going to gather the data that you're going to feed into the aging management program?
So we planned to restart the reactor, but the problem with our reactor is the IC is obsolete. So around there are SSC, so we have to follow that SSC to know when we will have that IC. So in which condition will be each SSC to restart safely. This is I can say the approach of this.
Any other question? Mr. Longa, I have a question. If I understood well, you received a NOMAR mission. Yeah. What are the main lessons learned from that mission? Can you just share us with us? Share them with us, please.
For the OMAR missions, so there was some recommendation, first of all, some recommendation for OMAR mission that we are, some of them are completed now, are done, and other are ongoing. So that we can say it was helpful for us to know that what we should do to maintain the reactor in the safe condition for from that recommendation.
Yes, thank you, Sergey, for this presentation. I am very pleased to see the progress in the reactor hardware, and as you mentioned that there is a plan for return to service the reactor, and we are certainly supporting this program, and the return to service after so many years of shutdown face some challenges, some important challenges. One is the aging of the system, the system and component, the structure system and components that you are managing very well, as you displayed very well during the presentation. And as from my knowledge, you are waiting also, you mentioned the instrumentation and control system, the renewal of the instrumentation and control system, which is the last point pending for the renewal of the SSCs. But there is another issue important in the return to service, that during so long time to shut down, so many years, the aging of the people, the retirement of the people, and you had to replace the people. And in a shutdown, in a reactor that is in long shutdown, this is very difficult because you cannot train the people in the reactor. So you can make some training for sure because you can operate some system, but you don't receive a full training for the new people. So how do you manage to get I don't know what is the date for the return to service you are managing now, because depends on the instrumentation and control system, but what plans do you have in order to be ready with both the installation and the staff for the for the safe operation of the reactors? So what are the provisions you are making now, and when do you expect to return the reactor to service?
Very good question. It's really that human now are, most of us are old now. And there are a program, like I say yesterday, our reactor manager, when my chief was present, his presentation yesterday, there are a process of recruitment of young person, engineer and physician to the reactor is planned, but he didn't put yet in the aging management program, but it's planned for son. And the second question was when the reactor we expect to restart. We are think around 3 years, if I agree with the reactor manager who is here. I think it's around 3 years we will plan from now. Yeah. Yeah. So there are many work to do too.
Thank you. Thank you very much. I just want to put some comments on what my colleague was saying regarding the human research problem that we are facing. Okay, I'm the reactor manager for Trico Reactor, and as he mentioned, we have drawn a plan for human research development, and also a plan for retention of personnel. Of course, as Mr. Mazi said, now the staff is getting old, of course, because of this long extension without working. But we are now a plan which is in place to recruit young people. We already started, and we rely on the IEA to assist us through TC program to train all those guys in the reactor. We are like the Trica reactor in Malaysia. Some people went in Malaysia Mr. Serge went to Malaysia, but the only problem that we have is how those people will be familiar with the operation of the reactor. People that we have trained are familiar with the management, the maintenance activities. The maintenance activities we are doing very, very well. But the operation, the operation of the reactor itself, this we have a problem because we don't have this INC system, the console. That's why we want people to be trained in some facility, Trica reactor, to assist them, to help them, to show them how to
to operate the reactor. And as my colleague said, the time frame for restarting the reactor, we expect that in 3 years' time we will be able to restart the reactor, depending of the money that the government will be put on the table for this purpose. I don't know if I make some clarification.
Yeah, thank you. We've heard from colleagues from Malaysia. I think that you have the same reactor. So, and they are also facing fuel supplies. So I don't know whether you're also envisaging to have some solutions on how you're going to proceed with fuel supplies. Yeah?
No, for the fuel, we don't have any problem with the fuel because we have easy mission it was in 2033 and 2019. We had two easy mission. They came and inspected the fuel element. All the fuel elements are in good shape. We also have fresh fuel elements available in the facility. So for the fuel elements, we don't have any problem. As my colleague said also, the reactor internals have already been checked also. There's no problem for that. The only problem that we have, as Mr. Ruben said, is the problem of staff and also the INC system that we want to modernize. Yeah.
Any other question?
Thanks. A question to our colleagues from Malaysia, Abdul. I just want to find out on the ISI for the heat exchangers and the reactor vessels and the pool liner, obviously. With regards to the type of ISI that you're performing, obviously it has to be the UT or NDE or eddy current. Are you doing it internally or you also outsourcing the tasks like we're doing in South Africa at Safari? The reason I'm asking, I want to find out if it's worth it investing internally so that obviously in the longer run you'll obviously save if you were to actually appoint someone internally that can do it full time. So are you following the same processes or you're doing it internally? Thanks.
The question is for who? Me or? Malaysian.
But you can also answer.
No, we don't do this.
Sorry, you're asking about the NDT use?
Not necessarily. What I want to find out, okay, for example, at Safari at the moment, we don't have the capacity to do it internally, so we outsource it through external suppliers. So I want to find out if you're following the same practice or you have some people that are doing it, that are appointed in the facility full time.
For Malaysia, actually we have a special department. Special department we call NDT, under the division of the industry technology. They have one department we call NDT groups. Actually, they are big groups inside our agency, Malaysian Nuclear Malaysia. So we get support from them. So they are not only support rector. Actually, they are support also another industry for like petroleum industry and others industry. So it means we use our own team in our agency to support rector. We're not getting from outside.
Oh, thanks. I think my principals are here, so they'll probably maybe take the advice. Thanks.
Any other question? Yeah, is that another question?
Yes, thank you. My question is for the TRICO 2 reactor, and still on the question about the human resource. Thinking about the coming back to the operation, and you said that you have the program for the replacement, but are you thinking also for the old people that work already there, a requalification in terms of examination by the regulatory body and a new license for them?
Thank you, Mr. Savini, for your question. Actually, we have, as I mentioned, we have a training and retraining program for our personnel, and for all personnel, they are to pass a requalification test, so that they can be with they can be qualified to operate again, continue to operate at the reactor. We have this program with the regulatory body in the country, and they do that. The program exists, of course, it exists. Thank you.
Any other question? Okay. Thank you, Mr. Serge. Now I give the floor to Mr. Abdulaziz. His presentation is about time-limited aging analysis as a basis of integrated management systems for research reactor in implementing of aging management program for critical ACC. You have the floor.
Thank you very much, Chairman. My name is Abdul Aziz. I am a junior researcher now working as the maintenance supervisor in the RSG gas reactor. So the table of content of my presentation is the introduction of the research reactor in Indonesia, and the second is aging management of RSG gas research reactor. And then number 3 is the time-limited aging analysis. The fourth is the time-limited aging analysis in integrated management system, and then the last is the future planning for integrated management system in our research reactor. Okay, there is a brief introduction of our research reactor in Indonesia. We have 3 research reactors. There are 3 Mark 2000 in Bandung with maximum output of 2 megawatt, and then the second is the Kartini reactor with maximum output of 100 kilowatt, and then the last one, the youngest one, is the multipurpose reactor Asiwa Besi with maximum output of 30 megawatt. So this is what my presentation about the RSG gas research reactor located in Serpong near the capital city. First criticality in March 27, 1987. The type is the multipurpose reactor, but the reactor itself is the material testing reactor. The fuel type is the uranium silicide. Operating mode is for 45 days per cycle with 4 cycles per year. And the license of the operation will be valid up until 2030. And the number of the fuel plates is 48 elements. So this is the schematic of our research reactor from top side view and the side view. So this is the reactor pool. Sorry, this is the reactor pool, the big one, and then in the side is the spent fuel. So and we have the delay chamber before going to the primary cooling system. So why is the integrated management system important to us? Because right now our previous organization, the nuclear organization, is already defunct, and that is assimilated to a bigger organization. So the current organization is called BRIN, the National Research and Innovation Agency. It consists of 6 research organizations, and our previous organization is one of them. And now our facility every nuclear facility is located in the Directorate of Nuclear Facility Management below the Deputy of Research and Innovation Infrastructure. So the organization has become bigger and it's really chaotic in our country. So we need to have a management system to streamline our aging management program. Okay. So this is the timeline of our aging management program activities. So the first one is initiated by the Batam and IAEA National Training Course on aging management on research reactor in 2003. And then in the next year, also there are workshops. And in 2005 is the EC of the secondary cooling system, and then we make aging management team in 2005. Okay. So this is the guidance that we use in order to create the aging management program for our research reactor. So the guidance is from the IAEA Safety Standard SSG 10 about aging management for research reactor, and then it adopted by our regulatory body, the Bapeten, and they make the regulation number 5 2022. And then from that regulation, we make our aging management program. So the regulation of head of nuclear regulatory body, the number 5 2002, is the improvement of our previous regulation, number 8 2008. And there are some changes in the regulation, especially about the interpretation of the critical SSG. So in our previous regulation, our critical structural system component is everything that is first-class safety equipment. So reactor pool, reactor components, primary pumps, and also the buildings. But because of the change of the regulatory, we use the graded approach method that is given by the SSG 22 about the safety guidelines of graded approach in research reactor. And then our regulatory body accepted that there is only 2 critical SSG in our research reactor, that is the reactor pool and the reactor core components. So these 2 components will go to the aging management program, and the rest will be to the maintenance program. So we have divided the equipment. So this is the schematic of our cooling system. And then the highlight box is our current critical SSG. So, and then the next one is the time-limited aging analysis. So right now we have the CRP with IAEA about the development of aging management program to support long-term operation of research reactor in Indonesia. So right now we have 4 years of cooperation with the IAEA to manage the time-limited aging analysis for our research reactor. And why is the LAA is important? Because it is mandatory from our regulatory body in order for us to extend our permit that is expiring in 2030. So, and then the document of reference is the IAEA SSG 48. This is for the nuclear power plant, because I think there is still not guidance for the research reactor in TLAA. So we're still adopting the nuclear power plant document. So this is our method for neutron embrittlement calculation. So we have 2 schematic diagram. The orange one is the experiment on sampling, sample like coupon of ALMG3. And then the green one is the simulation using MCNP and Origen. Then we also calculate the corrosion rate of our materials, namely the aluminum magnesium 3. And then we immerse in our reactor pool, and then we calculate the rate of degradation or corrosion. Okay, this is the step that we need to follow. The first one is determine SSG, which are referred as critical components. This is what I just say before. And then the second one is compiling the data. So we need to have the data from design and then commissioning and then every maintenance up until now, until present. And then conduct testing and simulation analysis. That is the one that is TLAA. And then the last one is determining lifetime of the critical SSG. Okay, this is some of our job in research reactor. That is the UT for the NDT measurement using ultrasonic testing to calculate the thickness of our liner pool. So we have the thickness in design, and then we inspect every year if there is any decrease in the thickness. So this is our result for the ultrasonic testing. So there are no significant decrease in our thickness, in our pool liner thickness. And then this is for the instrument inspection that is headed by Mr. Ruben Mazi in 2023. So the purpose of this EC is to check if there is any defect or degradation in the internal pool by using the camera, and then this is the result. So we have conducted the inspection in 2005, and then the current result is in 2023. And in the future, we will considering to use the IC again in order to determine if there is any changes in our internal pool. Okay, next. So this is one of our experiments using the X-ray diffraction to analyze the content of our material, the RLMG3. So we have a coupon that is irradiated for 1,000 hours, 3,000 hours, and 415 hours. This is also the experiment that we done that using the SEM method, and then we can see that there are defect that is happening because of the neutron embrittlement. This is the simulation of using Origin to determine the component that is irradiated in our reactor pool. So we have the initial, that is the RLMG3, and then after 30 years, and we can see there are some component that is that have been changed. So the component changed. So you can see in this table. So there are changes in the content of the material. Okay, so this is the timetable that NDT that we use from 2014 and 2024. So it's still not updated for 2025. So we have conducting the visual testing, the UT listening testing, then also the UT wadding, UT thickness, eddy current for exchanger, visual testing for the core structure, and many more. But right now we are focusing for the aging management program for the critical SSG, that is the reactor pool. So this is the integrated management system. So there are 4 pillars that we need to adopt. That is the IAA safety standard, the safety report series, the ISO standard, and the regulatory body Bapeten regulation. So for the IAS3 standard, there are SSR3, GSR Part 2, and then for the safety report series, there is SSR number 75, and then for the ISO standard, there is the ISO 9001, 14001, and 194043. For the regulatory body Bapeten is the number 5, 2022. Okay. The implementation of TLR in aging management program results in more comprehensive system maintenance activities. Maintenance activities become more scheduled and can reduce repair activities by increasing preventive maintenance before serious damage occurs to the system. maintenance management become more focused with scheduled maintenance activities and is focused on critical SSGs and SSGs related to safety. Management coordination from supervisors to worker is better conveyed with targeted action and spare part based on TLR analysis. Increases safety in maintenance activities by conducting risk assessment on critical SSGs and the impact of damage caused by the failure of this system. So the current status of EMS in our research reactor, so the maintenance is still using outdated repair manual that is from the beginning of the commissioning. And then the communication for maintenance activity is using bottom-up communication, so from the worker in the field and then step up to the top management. So it takes a long time for the top management to know what happened in the field. And then the database is outdated and missing many data, including design, commissioning, which is still in physical document and not been digitized, so still hard copy. So we're now working to digitize everything. And then maintenance activity is not focused on preventive maintenance, so we're still using the repairing equipment that because we not know when the equipment will be damaged. So the future plan for the IMS is creating database which contain all documents related to reactor design, commissioning, operation, and maintenance. The second one is the creating online monitoring system. The third one is using software which can predict lifetime remaining of the critical component. Number 4 is the scheduled periodic management and safety audits. And number 5 is the creation of the maintenance group based on analysis of the remaining life of the SSG. So this is the improvement that we already done on database system. So right now we have the database for the operation, maintenance, and aging management, the same as the Malaysia, I think. So we can see that we have the target of maintenance program that is 2,817, and then right now we only have done 2019. So we can see which one that we already done and which one that we still haven't done in 1 year. So this is updated real time, and then we can see what equipment that is already breakdown and what is the future inspection that we want to do. And then the third one is the cloud storage for compiling every document related to maintenance program, the safety operational procedure, the safety analysis review, and many more. So the worker and the top management can access this database, and then they can know real time about the current condition of our research reactor. But it's still on, we're still improving these databases. So the conclusions, that is our reactor currently operating normally, and then the operating license will be expiring in 2030. In order to extend the operation permit, we need to conduct the TLAA because it will be compiling in the safety periodic review that will be created in 2027. So we need to submit the document in 2027 to our regulatory body. And then the collaboration with CRP IAEA is already ongoing from 2024 to 2028. And then transition from previous organization to current organization provided both challenges and opportunity for nuclear to grow in Indonesia. And then the TLAE will be the basis to upgrade our management system, will streamline our maintenance, communication, and safety analysis and review. And then the last one is revitalization of measuring equipment and methods are needed in order to minimize data error and increase accuracy for the lifetime analysis. This one is still ongoing because we're planning that in 2026 to 2029, we are focusing in revitalization of the instrumentation equipment. Okay, thank you for your attention.
Thank you very much, Mr. Abdelaziz, about this interesting presentation about the time-limited aging analysis as an important tool within the aging management program. Now I would like to open the floor if there is any question.
Thank you very much. During your presentation, at one of the slides, you showed a picture that during inspection in 2023, you found a crack in the vessel welding joint, right? Have you observed any leakages, and how did you manage it? This one, right?
Thank you for the question. So in the previous inspection in 2005, we found that it's something like a crack right there. But because of the limitation of the resolution of the camera in that time, in 2005, we cannot have how should I say it? Because of the resolution of the camera is still really low, we can have a conclusion that if there is a crack or not. So we just put it in the report and we tell the regulatory body, and then they ask for to use the current camera in the 2023 in order to have a better imaging of the site that is look like a crack. But after we inspect it, it's not a crack. It's just like a filler that is, I think, too much heat that is when welding. So it's still there is no crack between the welding. And IAA they give us the document about the result, and they said this is not a defect. So that is what the best that we use for the regulatory body in order to close the inspection.
The IAEA stated that it's not a defect.
Yes. Because we are using their equipment and their manpower.
Hello. Yes. No, the AEA didn't state about the technical issues. The AEA is arranging a expert mission. So the expert mission calls for some expert, international expert, participating in the mission, and the expert that we recruit, they provide a report about the condition of the reactor, or what was inspected in this case is the tank of the reactor. What happened with this defect is that they had previous inspection in 2005, and the people that inspected the reactor at that time identified some defect that they presumed that was a crack. But when we inspected in 2023, the inspector, we have qualified, we call for qualified inspector on visual inspection. So they put the camera with different position, different angle, different lighting, and they conclude that as you can see, in the bottom is dark and in the upper is not dark. So this is a question of the lighting. So the conclusion at that time was that this was not a crack defect, and there is no evidence of leaking. So this is another issue, no? But yes, you must be cautious when you say that the agency says, because the agency doesn't hold responsibility. It's the expert, and what is the agency hired expert, but it's the expert statement, not the agency statement. Okay.
So it's not correct. It's inaccurate performance welding joint, right?
Sorry.
It's not correct. It's inaccurate performance welding joint.
Yeah, it's the material that they use when welding that has an excess, and this is the result. It's an excess of adding material for welding.
Thank you. Any other question? So, please.
I would like to make a comment because I know that Abdulaziz is doing a very good job with the aging management of the facility. But I was attending the presentation of Kus yesterday, that he talked about the 28 years that he was in the reactor and all the historical milestone in this process. And I found some interesting lesson learned that can be very helpful for BRIN in order to undertake the same or similar pathway. Because last time yesterday, Kus mentioned that in the 90s, you were utilizing the reactor in very low levels, only for some research or minor, they use the reactor from Monday to Friday, so it was a very low utilization. So, because of the changes in the in the country or the policies, the government commit the staff to make self-sustainable the operation. At least 70% he mentioned at that time, no? 70 to 75. So, and I found a very parallelism, a very good parallelism between your case now and the case that faced South Africa in the 90s, because you have a very powerful reactor. You have a 30 megawatt reactor. This is one of the most new reactor available. You have it's not very old, it's 30 years old. And you have not only the reactor, you have several facilities. You have fuel fabrication facility, you have hot cells. So you have really a lot of potential there that you are not using. So I think you had to see closely the experience of South Africa, because and on top of that you have a country of 200 million of people or more, so which is a lot of demand for radioisotope. So you have all the conditions in place to make a historical success like South Africa made. Of course, you had a lot of challenges. There is not one day to the other, but you had to think in that way and to probably get close to Nexa in order to learn how they did it and try to, because I was working in research reactor for many years, and for me it's very sad to see a lot of potential not used in the reactor, no? So I strongly recommend you and your manager of BRIN to take a look at this process and to learn how to revert the situation that you have now in order to be more productive and to produce radioisotope for your people, to the benefit of your country. That's my reflection on it.
So thank you very much. Thank you very much, speakers, for these very interesting presentations. Just gave them. Thank you very much, the audience, for the fruitful discussions. It was a very, very learning session. Thank you so much.
Thank you. Can you put up the mic? Okay, thank you. Thank you, Chairperson of the session. For the first time, colleagues, I think we are finishing on time. We made it. We made it. Thank you. You're a good chairperson. You manage time well. All right, it's fine. I think maybe let us talk about the closing session, colleagues. We're thinking of coming back here at exactly 11 o'clock, and then we are planning 1.5 hours for the closing session. So I think the administrators are telling me that if there are still people that needs to register to go to Safari, we are planning to leave here at 1 o'clock or just after lunch, depending on it. Can be 1 o'clock or 1:30. Then we will depart to Safari. please make sure that if you need to go to Safari, you should have sent the passport long time ago for the security approvals. So I think they are very strict in terms of the security protocol. So if we received your passport late, unfortunately, you have enough time to enjoy the mall. Then I think we picked up a card. It's room 204. Please come here. We pick up a card if we can. So enjoy your tea break. Let us meet here for the closing session at 11 o'clock. Thank you. late from the closing. Welcome to the closing session. I think it has been a very difficult 2 days, but I think we've managed. I think let's start with the closing remarks. May I please request the stakeholders to come in front. NNR, our labor colleagues, South African young nuclear professionals, WINSA, Women in Nuclear, and our IAA officials. So we will start with the proceeding. The first is from our sponsors, INVEP, Rosatom, and I want to pronounce it correctly. Is it?
Hetman Strauss. Hetman Strauss.
Yeah. Hetman Strauss. Thanks. Is there any Rosatom representative? All right, then I think without the waste of time, we'll give INVEP just the closing remarks, 5 or 10 minutes. Can you please load the INVEP presentation? Thank you.
Thank you, Sami. This is working, right? Yes. Okay. Good morning to everyone, and thank you to Sami. I want to start thanking Sami because of all the help that Sami and his team, specifically Nonjabulo, who has helped us since 1 month ago with all the staff to be here. So thank you very much for that. I just want to share with you a little bit of my own takeaways of this week. I was thinking it was a week, not 2 days, so it felt like a week, and I imagine for you too. And the first thing will be to, I think you have the change?
Yeah.
The remote is there.
Can you, a pointer?
So then, first takeaway, why this week or why this sort of event matters for the community? The first one that I want to stress is that as you have experienced, research reactors are not just a facility or not just an installation. They are more platforms that allow a lot of other activities surrounding the research reactor to happen. And events like this allows the face-to-face interaction between operators, regulators, researchers, vendors, and that specific events are very particular and very valuable for the activities that every one of us will continue doing when we go home. One of the things that is very important is that in this kind of events, we can see and we can share which are the goals of everyone involved. And we can identify which are those shared goals. And from there, we can work and start working together. So that's the first valuable thing that I wanted to share with you. For those who doesn't know that much about INVAP, we have had the Argentinian stand. We have shared a lot of interesting conversations there. We receive a lot of questions, and we have received a lot of comments. The Argentinian stand, I said, because it was not only INVAP. We were also in this event with our colleagues from the Atomic Energy Commission of Argentina. And I will mention it a little bit later, but this is something that a message that I also wanted to convey to you. It is not only a company who, as we are, who is attending and who is proposing to share our capabilities to the world. It is the whole country, the whole nuclear ecosystem of the country which is behind that possibility of INVAP to sharing these technological capabilities. So who we are? We are a company, a technological company in Argentina with 50 years of existence, starting in nuclear, but with time we developed other 3 business units. At the moment we have these 4 business units, nuclear for sure, but also we develop technological projects in space, in defense, and in nuclear medical systems, which put a very particular condition on us. There is not that many companies in the world able to combine these particular subjects. And one of the things that we share with the other business units is that the products that we develop cannot fail. And that put a lot of stress and conditioning on how we develop the projects. If it is nuclear, cannot fail. You know that we have this concept of defense in depth and all the safety systems around the nuclear. If it is in space, you cannot fix anything there, so it cannot fail, and so on. So that's a very particular condition on how we do engineering and how we develop our technological projects. In particular, in nuclear, we have a experience in developing research reactor projects in the whole life cycle of a reactor, of a research reactor. I mean, not only from the very beginning of the conceptualization, the designing, but also on the construction phase, manufacturing, procurement, commissioning, installation, commissioning. And then once we hand over the facility to the owner, which happens during commissioning, we continue the assistance during operation and for maintenance activity, for specific changes that are needed during the operation of the reactor, or some refurbishment work, and then up to the end of the life cycle of that facility. So we have that capability. And as I mentioned, collaboration with the client, with our partners, and the main one that I mentioned before is the Atomic Energy Commission. Why I say that? Because maybe this is something not that much known. I still receive comments from people that says, I didn't know that Argentina has these capabilities. And then it's important for me to tell you that there is a old and healthy nuclear ecosystem in Argentina that was developed starting from the work of the Atomic Energy Commission. The Atomic Energy Commission in Argentina has more than 70 years of existence. And a lot of companies, as my colleague Pablo Cantero mentioned in his presentation, were a spin-off of the work that the Atomic Energy Commission did. One of those spin-offs is INVAP. And so that is something always interesting and valuable to keep in mind, that it is not only INVAP, it is the Atomic Energy Commission, and it is also other companies and organizations that form also part of the nuclear ecosystem in Argentina. And that ecosystem covers from the training of the specialists that needs to be engaged in the nuclear programs. The Atomic Energy Commission is one of the main preparers of those special human resources, but also the whole university system of Argentina. And then there is companies like us that develop technological projects, but for the developing of those technological projects, at some stage you also need the support from other companies. And then again, back to the Atomic Energy Commission. The Atomic Energy Commission are the operators of the research reactors in Argentina. So all that experience in operation, in maintenance, in development of requirements for the research reactors comes from them. We have a company also that's able to build the fuel elements, starting from the design and the developments of the Atomic Energy Commission, but in an industrialized way. There is a company that can provide the fuels, and so on. So it is not only INVAP. If you engage with INVAP, you engage with the nuclear ecosystem of Argentina. What is our approach? And I like to say this, that I think this is as a company, it is our differentiator or our superpower, let's say. We listen first. We try to understand which are the requirements of our clients, and then we adapt to the specific conditions that every client or every I like to tell them they are not a client, they are a partner. And then this is something that we are proud of. We don't think there is a one size that fits all. Everyone has their particular requirements, their particular needs, their particular context, their particular regulatory scheme. So in this sort of project, we believe it is important to have that into account. And because of the flexibility that everyone wants for their facility, I think that a little bit put us in that obligation of being flexible. And at the end, what we obtain and what we aim for is a long-term relationship that doesn't end with the completion of one project. In our experience, all our clients have been continue talking with us, requiring information and developments from us. In the same way, we are very interested on knowing the experience that they get with the facility that we develop for them. So, which is, again, very valuable information for us. And from every new client, what the development of the projects that we have with every new client, it doesn't start from scratch. So there is a whole history that has been built in these 40 or 50 years of existence of our company that supports the initial developments of a given project. And in that sense, it is a learning for the partner. It is a learning for us too, because as I said, every new project is slightly different to the other one. Sometimes slightly, sometimes very different. So that for us is also a learning thing. And then that was the reason we selected to show during the presentation that my colleagues from the Atomic Energy Commission and from INVAP have presented during these days here. We choose these 4 projects that are on the screen because they are currently projects in development. They are not only on paper on the computer. They are projects that are in some stage of realization. And that is also something that we strive for. we want our projects to be finalized. We want our reactors to start first criticality and then operating. That is the achievement that we look for. And from every one of them, we have different lessons. I'm not going to extend that much, but you can imagine that having them different sizes, different set of requirements, different context, regulatory context, and different local context give some different lessons to everybody there. With Africa, INVAP has a long-standing relationship. With Algeria and Egypt, we have been working in the last century, in the 80s in Algeria, in the 90s in Egypt, and as I mentioned before, that relationship has continued over the years. And we are now in Uganda, doing the first steps in new programs there. So as you see, we are going south. Then a little bit more about what Argentina brings to the table. As I mentioned, it's the whole ecosystem of Argentina. It is a full research reactors life cycle science experience, as I mentioned, through the experience of the Atomic Energy Commission. We have here with us the manager of one of our research reactors. In fact, of that research reactor in the picture, Area 6 in Bariloche, that is in the city where we live, where at the headquarters of INVAP is located. And it is one of the main training facilities for the country. So I mentioned it before, there is this institutional support coming from CNEA, the universities and the industry. And we, among all of us, we want to provide these flexible solutions aligned with the national goals of every country. And again, we say this is partnership. It is not transaction. It is a partnership. And for us, partnership means different things, all in parallel. It means that the planning of the project is shared with our partner, our client. We adapt to the local capabilities. That can means different things. It means that we are open to receive the capabilities of a given country if they are available, and if they are not, we strive to find those, to fill those gaps. We also work, of course, with operators, being local or not, because that gives tremendous information and valuable information about how a reactor, or what kind of things do you want to do with a reactor, or what kind of things you can do with that reactor, and how it behaves, and all that kind of things that is permanently fed to our designs. And also with the regulators. Normally, this is not directly with the regulators, but through our client, which is the institution or the organization that is normally the licensee, and that they have this direct communication. But we support our client in having this kind of conversations, and we encourage our clients always to have an early engagement with the regulators, because that is something very valuable even from the very early stages of the design. And then what we say, capacity building is not optional. So, and this is whatever the situation of the country. It could be because there is a lack in number of enough persons that can support or that can provide the knowledge that is required, or maybe we are working in a very capable country with that enough number of resources, but they don't know that much the facility we are providing. So that capacity, that knowledge building, I would say, it's mandatory in any case. And then we support and we put our effort in order to do that transfer of knowledge. And then I think this is one of the latest one. This is just what I have seen during these days that are possible areas of collaboration, taking into account all the presentations that I have attended and the ones that my colleagues have mentioned to me. So there is an area of new reserve reactors. Of course, we are very interested in participating on that. But there is also some work to be done in the modernization, refurbishment, conditioning of existing facilities. That is also a field of work where we can support. There is a whole work on training and capacity building, on providing the proper competencies for the operation teams, where, as I mentioned, this is not a direct work from INVAP, but this is work that the Argentinian nuclear ecosystem can provide. And then there is several other fields of potential collaboration on the production of radioisotopes. That's a huge work on there. There is on providing support in terms of regulations from our own regulatory body. Again, is the an Argentinian ecosystem, but it is also our own experience as vendors dealing with different regulatory schemes and regulatory contexts. So that experience is also something that we can share with the community. There is also a lot of stuff related to basic science, to utilization of the reactor, utilization of the neutrons, and how those neutrons can be applied for developing some nuclear science studies. And so just to finish, this is the message I wanted to convey is just to repeat this. We believe that the reserve reactors, this is a conference on reserve reactors, is a very active community at the time. I'm very glad to be back in Africa and to be back in South Africa. I used to work here many years ago, and then I see a very active community that still wants to achieve maybe the impossible, that you are thinking on that, and we are willing to support you in those endeavors. So thank you very much, and yeah, thank you for, I hope I wish you a safe trip back to your homes and a successful roadmap in your different projects. Thank you.
Yeah, thank you, Philip. I think, as they say, we have given you much airtime. Thank you. Thank you very much. Thank you for your support. I think I'll hand over to the next sponsor in terms of attribution, it's HNS.
Thank you, Sammy. I was hoping to see our logo there because it's been hiding away in places. So my name is John Matheson. I'm a nuclear advisor with Hedman Strauss, which is a proud sponsor of the conference. It's been a fantastic conference, I would say. And congratulations to the organizers on this, and I'll come back to some words on the conference. Say a few words about Hedman Strauss. We're a South African financial services company for sustainable energy projects, both here in this country and also internationally. And not just, and it's a broad range of energy projects, but it does include nuclear as well. So our services include project development, financial guarantees, credit provision, and so on. And one particular area of interest, of course, is insurance, third-party nuclear liability insurance, which is a hot topic at the moment internationally. So we're not just financial advisors within the company. We also, I think our strength is also that we have an international network of technical and legal associates covering the nuclear and other energy specialisms. And our clients in South Africa includes Nexa and Eskom, and also around the world as well. Many of the nuclear facilities around the world are insured through our brokers that we are associated with. To come back to the conference, I've been 50 years in the nuclear industry and started life on a research reactor, the Consort reactor, Imperial College London, many years ago. It's now been decommissioned, and some people say I should be decommissioned as well, but that's another story. So I was very interested in the aging management and the lifetime extension discussions that we've been having. One thing, as perhaps a suggestion for the next conference, so the conference has taken us through the operating, the building, the operating, the lifetime extension, the aging management, and so on. But an important aspect, and this is where my background comes in, my background is nuclear waste, and I think perhaps one thing maybe for the next conference is to look at the decommissioning of facilities, because that's going to be an important aspect. We've heard many reactors spoken about during the conference are reaching their 50th anniversary or their 60th anniversary or their 65th anniversary. So the time will come for them to retire as well. But what happens then? What do you do with the fuel? What do you do with the waste? You may have arrangements in place, you may not, but that's, I think, an interesting area for discussion. So once again, Mr. Chairman, thank you for putting on a fantastic conference. I echo Felipe's remarks in please have a safe journey home, and we hope to see you again at the next Research Reactor Conference. Thank you.
Yeah, thank you, sir. In South Africa, colleagues, we've got important stakeholders. I'll start with the National Nuclear Regulator to provide the closing remark. I think maybe colleagues, you can be brief, and then we've got the South African Young Nuclear Professional, and then in our midst, we also had the Women in Nuclear in South Africa. If that's a representative, we'll give you just 5-minute remark. Then I want to give to the EIA official so that we can still close on time before 12:30. Please be as brief as you can.
Okay, thank you. Distinguished guest, representative from the Department of Energy and Electricity, IA delegates, international delegates, as well as the organizers of this conference. Let me take this time to congratulate you for organizing and participate in this important conference. We as a regulator would like to emphasize that safety remains the overriding responsibility in operating the nuclear reactors. As we close this 11th African Conference on Reactor Utilization, we would like to extend our appreciations to operators, regulators, technical support organizations, researchers, government representatives, industry partners who enrich discussion with expertise and experience. Over the past days, we can confirm or reaffirm that safety is a continuous improvement and is a shared responsibility. The insight on operational experience, safety performance, emerging technologies, risk-informed authorizations, regulatory expectations, and capacity building has been demonstrated in our region that is now maturing, and there is dedication to the highest standard. As I look back from 2017, when I attended this conference, it was in Ghana, in West Legon, and there were few delegates in that particular conference. But in this one, I could not recognize most of the people. I can see that there are new faces, but I would like to actually maybe mention the few people that I can recognize. The IAEA representative, Ms. Nasir, whom we have interacted in the Code of Conduct of Research Reactors, IRSRR meeting, and Mr. Felipe from Argentina, who worked here in South Africa, who has transferred a lot of skills to our young people. We recognize you for that. As well as Mohamed Salih from Argentina, not from Algeria. I remember my first meeting when I went to Algeria, they said we must contact him. Now, when I was phoning his office, there was one guy who was speaking Arabic. He will always say, Salim alaikum, Salim alaikum. I say, Salim alaikum. And the conversation could not continue. The next day, it will be the same thing. On the third day, I had to write him an email. Then after that, I was able to communicate. The last person is from DRC Congo, whom I know for 20 years now, Mr. Kombele. I would like to say in the true African spirit, Mbote Malamu. Yeah, as a regulator, our mandate remains the same, is to provide independent, fair, and transparent oversight aligned with international standards, while focusing on learning and improvement. And the conference reinforced the trust and the shared commitment to safety. Public confidence in the nuclear technology is earned through consistent and responsible decisions. Our work is not only technically, but it carries ethical and societal responsibility. Communities depend on all of us, both the regulators and operators, to ensure safe and secure as well as compliant operations. As we conclude this conference, I encourage you to take forward the lesson learned, challenges identified, and commitment made. As you return to your organization, you must return with renewed purpose, stronger partnership, collective determination to remain vigilant. Thank you.
Thank you, thank you. That was short from the regulator. Thank you very much. Then we'll move to the South African young nuclear professional. And then if WINSA is represented, you can come. Please just be short, brief, 5 to 10 minutes. Thank you.
Good morning, colleagues. Can you hear me? Can I? All right. My name is Emmanuel Muntwedi. Meeting you again. I was facilitating a few sessions during the week. I'm the chairperson of the South African Young Nuclear Professional Society. We are a South African youth-based organization in the nuclear industry. The objective of the organization is to ensure knowledge transfer between those that know and those that are joining the industry, which is normally the young professionals, to ensure skills development within our young people, because as we know, the nuclear industry is a long lead industry. Some people were presenting yesterday or day before saying the average age of reactors is 55 and 60 and 40. So if you joined the industry when you were 20 years old, how old are you 40 years later? So we need to ensure a continuous pipeline of young professionals into the industry so that we can maintain the industry going forward. We have members from industry, meaning from NECSA, from NTP, one of the sponsors, from the regulator, from ESCOM. They are not here because they produce power and not do research. And then members from academia in various universities around the country. I'd like to say we support these kind of initiatives, these kind of conferences in the region. It's important that we learn from each other. One of our colleagues yesterday was joking, saying, after looking at the Palace timeline, she was saying by the time the MPR is commissioned, she'll be ready to retire. She's fairly young, by the way. But it shows that there is a need to retain knowledge, to retain skills, and to transfer it. And this will encourage, the entire region, not just South Africa, to involve young professionals in all spheres of the business, governance, operations, and all the way to decommissioning and waste management. This is the only way that 50 years from now, the industry will still be in existence. I'm looking at some of my colleagues from NECSA. They joined, they're a little bit older now, but when they joined, they say they were very young men. Some of them have retired. They were sharing knowledge here today. The only reason we are able to still get this knowledge from them is because when they were young, no one ignored them. No one sent them to make coffee instead of doing work. So it's important that we bring young people along. I want to highlight a few things. In South Africa, there's a few key projects. The NECSA is talking about the MPR, which is to replace Safari 1. I'm not sure when this will be commissioned, but involve young professionals so that by the time you commission, you still have the operational knowledge. You know why you chose this vendor and not that vendor. You know why you used this bolt and not that bolt, because someone will remember. The Safari long-term operations, you want to extend the plant life by 10 years. If we still can, another 10 years. So that's a long time. So let's involve young professionals in that project. I'm going to talk about Kuwek, even though they are not here. They've extended the plant life by 20 years with a potential to extend by another 20 years. So that's 40 years, right? So the South African nuclear industry average age is close to 50, it's 47 years old. So if you're extending by 20 years, 20 years from now, that person will be 67, retired and hopefully still alive. The South African life expectancy for men is 65 years old. For women is 69 years old. So by the time we go for a second extension for Quebec, if numbers don't lie, majority of these people who are 47 years old may not be alive. And if we do not manage this knowledge transfer properly, we will lose all these skills and operational memory. The nuclear PBMR, which has recently been lifted out of care and maintenance, one of our Chinese colleagues presented on a similar technology yesterday. The research is not done. It will take a few years to complete the research, to build a demonstration plant, and to eventually build a commercial plant. We need to ensure the skills pipeline for this program in order for it to be sustainable in the future. Our nuclear waste storage facility wants to expand and build for long-term disposal in order to support the nuclear industry. These are long lead projects as well. We need to involve young professionals there as well to retain operational memory. So the bottom line is that let's work together. Let's have we are the youngest continent apparently in the world, the African continent, with the lowest average population age. Let this reflect in the workforce. Let's ensure that we maximally benefit from this thing that other people are saying is a strength. We don't know if it's a strength until we utilize it successfully. And just in closing, so that I don't labor too long, let's believe in ourselves a little bit as a continent, a little bit more than what we are doing right now. We are capable of doing great things. If you study the history of the continent, you'll notice that there's many, many inventions that came out of us. So let's go back, involve our young people, plow back the seeds, and build a sustainable nuclear industry in the continent. And the last message to the sponsors, I want to say thank you. It's important that you don't just look for money to make profits from the continent. It's important that you also plow back and ensure that in the future, there'll still be a place that you can work with. That is highly appreciated. Thank you so much.
Thank you. That is our South African nuclear young professional. I think the message is profound. We discussed the human resource issues in Africa in terms of operating the reactors. I think we have exposed them. The conference is one of the exposure. So you have seen what is happening or what is actually required from young professionals in terms of institutions like the research reactor. Thanks for that. I think I'll move to the women in nuclear before I take our labor guys. So Edzani, our program director, is a representative from Women in Nuclear in South Africa. Then she can provide us a perspective. Thank you. Welcome, Edzani.
Thank you. I'll try and be brief. So we are Women in Nuclear South Africa under the WIN Global movement. And our goal is really just to encourage the participation of women in the nuclear field. And we always encourage in all aspects, whether you are in finance, whether you are in actual research work, or even somebody who is just working as a cleaner. We always then try to say, be out there as a woman and represent women in the industry, share the importance of the nuclear technology within your communities, because women are known to be nurturers and caregivers. So when we look at how nuclear medicine plays a role in cancer treatment, we encourage women to share the importance of nuclear technology and how it impacts their lives. So we have different chapters within the South Africa, and NEXA is one of the chapters. We do have women from the regulatory. We also have women within the power industry, basically in all nuclear aspects. we are covered in that aspect. And let me just stop here. It's also good to just see quite a few women participating. So it shows that there is inclusion within the industry and there is participation from women. Thank you.
Thank you, Edzani. Moving right along, I think we'll give a floor to NEHAWU. It's a federation, it's an important stakeholder, it's a labor movement in the nuclear space. So over to you, Mr. Mashele.
Thank you, Program Director. Good morning, colleagues. As Mr. Malaka has indicated, my name is Aaron Mashele. I'm the chairperson of NEHAWU, which is one of the labor movements that represent employees within the sector. It's a national union, but we organize, I will focus mainly within our sector. We do organize within the Department of Energy and Electricity, NNR, NEXA, RWADI, and NTP, etc., and all these other subsidiary entities that are within the nuclear industry. I think we want to thank firstly the organizers for inviting us, and to thank as well as the sponsors for sponsoring such a successful conference. I think our purpose was clear, was a very brief one, because all of us, before we are managers and scientists, we are just ordinary workers. And I think it's important that we do demystify and dispel some of the misconception about the role of the labor movement within our sector. Look, ours, it's a simple one. We exist for primarily two reasons: to ensure job security for our members within the sector, but also to ensure that there is an improvement in the conditions of service of our young people that Emmanuel was talking about. We believe that happy employees are productive employees. Happy employees are employees that are able to operate these very important facilities, the reactors, in a very safe manner, because they are not too worried about their family, socio-economic conditions, because the organization that they work for do take care of their needs in a fairly reasonable manner. Of course, it will never be enough, but if employees feel that the organizations they work for do try to look after their interests and not just use them as mere instruments in just in the whole value chain that can simply be discarded, but they are valued, they are very likely to be more productive. We're also likely to retain them more within the nuclear sector or the nuclear industry, because when you deal with engineers and scientists, operators, technicians, etc., there's also a competition in the market for these kinds of skills. If we're not looking after their interests, chances are we are likely to lose them. And that's where we come in as labor, to make sure that while scientists and engineers and technicians are focused in what they do best, which is to run these very critical facilities, ourselves, who ourselves are professional, can make sure that their interests are looked after. Look, as we've indicated, our approach is simple. We've got two strategic approaches. We work, and we have worked very well with management to complement them, especially where they are doing the right thing. We have always complimented them. We have always tried and also play our advocacy role for our industry to make sure that, because we are not just a local-based union, but we are a national, as Semi has indicated, we have got our federation, which, given the unique position in South Africa, where we have got a ruling party that is in alliance with even the Labour Federation, means we're able to lobby, whether it's issues such as integrated resource plan, Hence, we have got a portion there of that is dedicated to nuclear. And I'm sure a lot of you will have heard a lot about the contestation that was taking place between the renewables and the nuclear. In fact, a lot of them will not want a nuclear to have space to be given. In fact, even the very life extension for Quebec, I think a lot of the groups were lobbying against, and that's where we come in via COSATU, via NEHAW national leadership, to lobby and make sure that the nuclear industry, it is indeed protected and continue to exist for the foreseeable future, or the longest future that we can possibly imagine, because it plays such a critical role. From where we sit, we said the nuclear industry creates what we call qualitative jobs, long-term, very sustainable jobs, but it also creates a spin-off effect, because if you have got the nuclear power like Quebec, because it's a base load, you can support a whole lot of other industry. In South Africa, we have seen what they used to call load shedding, where the demand for electricity outpace the available supplier, because we have not invested enough in our base load. And we believe that with the support of the new minister and the work that we have done in COSATU and NEHAW, that's why we are today speaking about nuclear having been included in the integrated resource plan. Today, we're talking about the multi-purpose reactor. I think we have got 1.2, 1.3 billion that has been made available for funding. We believe it's just probably 1/10 of what is required, or if not or 5% of what is required. But we believe that these projects, again, with lobbying government, will get more funding to make sure that we do have a replacement for Safari when the end of its life comes to an end. There must be another replacement. The nuclear industry in South Africa cannot exist without another multi-purpose reactor or Safari 2. So colleagues, I think even those of you who come from different countries, and I think it's important that we change how we engage with even the labor movement, because it could be and it can be, as we have demonstrated in ours, that we can be a very critical stakeholder that assists in building a fair, a just, and a sustainable nuclear industry. We are looking forward to technical sponsors when we go into a new build program for the new nuclear power plant and our multi-purpose reactor construction to work with you. And we are looking forward that, as Comrade Emmanuel has indicated, we'll be involving young people so that indeed the industry is more sustainable. We're involving women in our whatever operations that we are actually doing. And I think it's one of the things that we do stand for as a labor movement. Colleagues who are going back, we wish you a very safe journey, and we appreciate having taken time to visit our country. We hope that the lessons that we have learned here will not just benefit yourselves as individuals, but will also benefit other colleagues and the countries that we are and the organizations that you are actually representing. Thank you very much.
Yeah, thank you, delegates. I think this is a unique proposition from South Africa. I remember the word, nothing about us without us. Thank you, Mr. Mashele. Okay, then we will go, we've got 3 more presentations. The first one is from the International Atomic Energy, just to give their closing remarks. I think you can come forth. Yeah, maybe we can excuse. Then we will have government official as well. Thank you, colleagues. I think.
Good afternoon, everyone. I think after the very impressive statements that we have heard from the South African chapter, youth chapter, as well as the WIN chapter, and the labor movement in South Africa, I am really reluctant to give a presentation because now the spirit is more like open discussion. So I'll try to be really very brief and go forward to the message that I would like to add here. This is a very brief presentation of the work that we are doing in the Technical Cooperation Department, Division for Africa, but I'm sure that the same is being done in other regions, in Asia and the Pacific, Latin America, and Europe. So the base of our support is always the member states' priorities. We rely heavily on the country program framework, and this is a strategic document that is signed by the highest level in the government, so that we can rely on the government commitment. And the program should always be in alignment with the national development plans that are usually linked to the SDGs. In Africa, we work very closely under the AFRA agreement, which is the regional agreement in Africa for training and research in nuclear science and technology. And this has been the case for this project. Research actors in Africa, maybe I should really skip this for the sake of time, because I was told that I have only 5 minutes. So this is all known for now. I would like to emphasize that we have been working with two categories of member states with research actors and member states considering research actors, and we have been fully supporting both categories. For the member states with research actors, there are national projects tailored to their specific needs, as well as regional projects that we come together to address common needs. For the embarking countries, we have also tackled individual national projects, as well as one regional project that has ended very recently. For the last 12 years, almost 12 years, we have been supporting 33 national and regional projects for both categories. And the target was, of course, to improve utilization of available facilities, enhance safety measures in accordance with IAEA safety standards, to improve also the operational management, support feasibility studies for the embarking countries, and provide a platform for networking and partnership among the member states from both categories. Why do we need AFRA project? This has been discussed throughout the 3-day conference, but I would like here to highlight that we will have a new project starting as of January 2026 for another 4 years. There are also national TC projects that are tailored to each member state. So we have one for Libya, one for Rwanda, one for Uganda, and one for DRC. The most important thing, the message that I would like here to convey is we need to build on the achievement that we have done, and we need to go further, but with partnering with all the stakeholders available in this conference. Some achievement of the project, we have been able to conduct 51 capacity building activities. We have trained 423 participants in different thematic areas, in different forums, such as meetings, scientific visits, fellowships, training courses. The budget of the project was around 800,000. We also received extra budgetary from major donors, such as the US and Spain, that supported some of the activities that have been carried out throughout the 4 previous years. Some of the achievements is, you have heard a lot of the achievements through the presentations during this week. I would like here to emphasize that we have been able to establish the Regional Advisory Committee for Safety in Research Actors in Africa, RASCA. Yesterday, we held the first meeting, and we have elected the chairperson and the vice chairperson for this committee. We look forward to working with similar committees in other regions in Asia and Pacific in particular, and also Europe, in order to find some synergies together and best practices to in fact benefit also from your own experience. Another milestone is the African Research Reactor Network. It will be established next week in one of the high-level meetings that will be held in Namibia. And this is also another call for synergies with the Latin America similar network. We look forward to benefit from their network, because I understand that they have already worked for more than 2 years now, and we are open to link with them and also to benefit from their best practices. I would like also to highlight that the agency is supporting a lot of advisory missions. These are some of the advisory missions related to the safety, the infrastructure, to utilization, operation and maintenance, as well as site selection. We look also forward to partnering with some of the experts in the room here to get the benefit from the experts in Africa for Africans. Best practices. This project was very effective in communication. I'm very grateful to all the counterparts, because they were very open to communication. We had very important, in fact, strategy that we have developed over the 4 years, and the end product of the project is very. In fact, we have been able to achieve all the outputs of the project, and we built also regional capacity using experts from Africa through using African experts mixed with other European and other. More advanced experts, so that they can learn through the missions. So partnership is welcome here. This is my main message. I welcome capacity building in the more advanced institutions in different regions, not only in Africa. So this is a call to reach out to us in order maybe to find some activities that we can organize together, or we can host either in facilities in Africa or in other regions. Here are some of the nice photos that we have been collecting throughout the years. So this is the walkthrough in Ghana, MNSR, 2 years ago, and this is the walkthrough in Safari last year. On the right side, we have the African school in Morocco, and on the left side, we have the participation in the ERI school. And I was requested by Sami to put this photo for you as an incentive for the forthcoming sightseeing tour this afternoon. And I stop here. Thank you very much.
Yeah, I think this is our next excursion for the cultural visit. Ladies and gentlemen, I think on the first session, Asa worked through the government with the National Liaison Officer, which is Ms. Lerato Mahai, but Ms. Lerato Mahai couldn't come for the closing session, so I think she delegated Mr. Haupalele Santswiri just to say a word or two from the Department of Electricity and Energy, the TC project under NLO. Mr. Santswere.
Much, program director and my project counterparts. So now I'm going to use my powers as and wear my government hat and be between you and lunch. So if I take long, just know I'm government. So, but I won't. So ladies and gentlemen, on behalf of Ms. Makhaye, she requested me to deliver some closing remarks. So distinguished guests, representatives of IAAE, our AFRA member states, and also members from our member states from other regions, colleagues from government, research institutions, our partners who are here, industry, ladies and gentlemen. As we conclude the 11th African Conference on Research Reactor Safety, Operations and Utilization, it is the honor of the department to deliver these closing remarks on behalf of the Minister and of the Department of Electricity and Energy of the Republic of South Africa. Over the past 3 days, we have witnessed a powerful demonstration of Africa's commitment to strengthening nuclear science and technology, advancing research reactor safety, expanding the peaceful applications of nuclear technology across our continent and beyond the continent. Your contributions have reaffirmed that Africa is not merely a beneficiary of global nuclear knowledge, but a growing source of innovation, expertise, and leadership. The conference brought together the very institutions that carry the responsibility of ensuring that research reactors across Africa operate safely, efficiently, and in alignment with international standards. The discussions we have held here, ranging from operational best practice to advancing application, human resource capacity development, and regulatory framework, will significantly influence the trajectory of nuclear research and development on our continent and beyond. We are especially encouraged by the strong spirit of collaboration displayed throughout the conference. Research reactors have long served as engines of scientific progress, enabling medical isotope production, industrial innovation, agricultural research, material testing, and the training of our next generation of nuclear professionals. Strengthening these facilities strengthens Africa's scientific sovereignty and expands opportunities for economic and social development. This conference carries special meaning for South Africa as we commemorate the 60th anniversary of SAFARI, a facility that has made extraordinary contributions to nuclear science globally and has positioned Africa as a critical player in the production of life-saving isotopes. As we honor SAFARI's remarkable legacy, we also look eagerly to the future with the government's approval of the multi-purpose research reactor, a next-generation facility that will deepen research, reinforce regional isotope supply, and expand Africa's capacity building ecosystem. Allow me to extend our sincere appreciation to the International Atomic Energy Agency for its unwavering partnership and continued support for Africa research reactor development, safety enhancement, and capacity building. The IAEA leadership and consistent engagement remain instrumental in enabling Africa to advance its nuclear research agenda. We equally acknowledge the contribution of all participating member states here, our AFRA partners, the distinguished experts, and the organizing team whose dedication ensured the success of this event. Your work exemplifies what is possible when we unite behind a shared vision for excellence in nuclear science and technology. As we close the conference, let us carry forward the energy and insight gained here. Let us strengthen our cooperation, deepen our technical network, and commit ourselves to building a sustainable ecosystem of safe, reliable, and innovative research reactor utilization across Africa and beyond. The work we do today lays the foundation for future generation of African scientists, engineers, and innovators. So on behalf of the Department of Electricity and Energy, we would like to thank each and every one of you for your valuable contribution. We wish you safe travel and continued success in your efforts to advance nuclear research and development on our continent and beyond. So I thank you kindly.
Thank you, Mr. Santswere, on that message from the government. I think we can load the 2 slides from Nexa. We are almost there, colleagues. Yeah, next slide. Yeah, thanks, colleagues. I think this is the last slide of today as well. We mark the end of this conference. We would like to extend our gratitude to our sponsors and our partners. I think from the government side, I think it was heavily alluded that the partnership that we are having with the International Atomic Energy Agency in terms of capacitation of our workforce, as indicated, and strengthening the collaboration, especially in our projects, as we move in the quest to ensure that we've got adequate and competent human resources. I think we cannot overemphasize the partnership that we are having with the International Atomic Energy Agency. I think in this sphere, to extend our heartfelt gratitude to yourself under the RAF 1011 TC project for enabling participation of a large African participant, as well extending to Mr. Ruben Mazi, where we worked a lot in terms of the preparation of this conference. Thank you and thank you. Then I think NECSA for allowing an opportunity like this to make sure that the delegates across the country can meet and exchange knowledge and empower each other as far as research reactor safe utilization and operation and maintenance best practices are concerned. So, and as well the sponsor NTP, which is the nuclear technology product arm of NECSA, for their contribution in ensuring that we successfully host this conference. I think we have given a platform to INVEP, Hetman and Strauss. They've actually articulated their point. I don't see Mr. Ryan Cole from Rosatom Energy South Africa, but we do extend an appreciation in terms of their contribution to ensure the success of this conference. I think most gratitude should actually also be extended to the participant who worked tirelessly in ensuring that they submit the abstracts on time, they prepare the presentation, they write the papers, of which I think I can share with the delegates that we will compile the proceedings of this conference and then produce a paper or a booklet that will be shared with you in terms of all the presentation that we have actually run through the 2.5 days, as well as the posters. To our keynote speakers, thanks for availing yourself, and make sure that you deliver those keynote addresses. It was valuable and very essential to the participant. To the local organizing committee, thank you for your dedication. As young as they are, I think they've pulled it through. They deserve a round of applause, ladies and gentlemen. To the scientific advisory committee who adjudicated on the abstract and make sure that we've got quality presentation for this session, we also extend the gratitude, and then I think I will name them in the next slide. So I won't go for the exhibitors. I think NECSA, Safari One, the RRT Oscar team, the NLA, as well as the multi-purpose project team, at a very short notice, I think they availed themselves. In terms of the other stakeholders that were not here, but they were here in terms of being online, and RADI, which is our National Radioactive Waste Disposal Institute, and then NUMERI, which actually run the hospital in terms of nuclear medicine. We say thank you for being with us online. WINSA, SANEPS, and how I think they've provided their remark. To the exhibitors, Thank you, and then I think you have done a sterling work in terms of exhibition as far as your offering is concerned. I hope you received quite value for money. To our new hotel, conference and accommodation services, thanks for hosting us for the 2 days. I think we are continuing as part of the TC Afra for the next 2 days. We'll be here until Friday to do some of the work under the RAF 1011 TC project. To our suppliers, our live streaming colleague, the suppliers with the conference badge, etc. Thank you for your dedication and excellence and supporting this conference. Lastly, I think from NEXA, on behalf of NEXA, I would like to wish you a safe trip back, especially for those who traveled from far, locally, and then also in our beautiful African continent, as well as abroad. I know my Argentinian colleagues, they've got a very long flight, so all the best. I wish you a safe trip back. I think we will now have to exchange gifts. Ladies and gentlemen, I think I declare this conference closed. Thank you very much. Bye-bye.
Just to say thank you for this organization and all the effort put forward to this conference that is very challenging. I appreciate also the attendance to this meeting, and we want to have a small present to you in memory of this conference. So, as a
Thank you.
You can open.
I must declare it. Okay, no, it's a pen. Thank you very much. I think for you as well, for allowing the participation. Thank you very much. I know, Ms. Nazir, for you as well. Yeah, I think. Okay, I think lastly, we will just request one of the local organizing committee just to brief the delegate in terms of the Safari One visit. Oh, Andre, I thought you are gone. We got your gift. We'll set it. It's one of the EIA official, Andris Sitnikov. Come forward, I think. Yeah. Maybe you must be in the picture, Andre. All right, I think make the announcement in terms of the safari visit. Thanks.
Before I make the announcement with regards to the tour, we just received a list from the hotel. There are people that are supposed to check out, so I'm just going to call out the name. It's Ige Hossein, Mohammed Salhi, Hebel Mohammed, Pong Sakom, and Andre. You have to contact the hotel reception for checking out. And with regards to the Safari One tour, please make sure that you have your passports with you. I think we have sort of confirmed with those that we got a list, we got their names. The bus is already here, and because of the long speeches that we had this morning, our lunchtime has been shortened. So we will please make sure that we leave latest 13:15. Everybody should be in the bus by 13:15, and we are hoping to be at Nexa by 2 o'clock. So no later than 13:15, please, let's be on time. So grab your lunch very quickly and be on time. And please, all those that haven't made payments for the conference meals, please make arrangements before you leave or in the bus. We need to make sure that all payments are done. And those that need airport transfers, please contact me so that we have your departure time and make sure that we arrange transport for you if you need transport back to the airport. And all those that were also picked up from the airport using the shuttle services we had organized, please make sure that you have paid the transfer fee. Thank you.
No, thank you. Then meeting adjourned. All the best, colleagues. Safe travel.